Lesson 7.2, your outcome. Determine the number of solutions of a linear system. Identify parallel and perpendicular lines. I've noticed some of you have started to drop writing this. You don't write it anymore. You need to pause and write down your outcome. You need to keep your notes nice and organized, especially for this unit, because every video is going to be different, and you're going to have several videos for this unit, okay? Before we move on, last time we talked about what a linear system is. Kind of recall that in your mind. If I asked you what a linear system is, what would you tell me? Okay? I would hope that you would tell me that it's two lines on the same coordinate plane. They are going to intersect at some point based on what we learned from last time. Identifying parallel and perpendicular. Okay, that's something you need to recall from elementary. What is parallel and perpendicular? What does that mean? Well, parallel means two lines that are never going to touch. And then perpendicular means what? What's special about this little corner right there? What is it going to form? Let me get it. There it is. It's going to form a right angle. Okay? So you need to make sure you know what parallel and perpendicular mean. Okay? Because now we're dealing with two lines and not just one. Alright, here we go. First things first, a solution of a linear system. Here's a plain old definition. An ordered pair that is a solution to both equations. That means it makes both equations true. Okay? And here's what I mean by that. Here's two equations. I just made these up. Okay? I want you to pause this video for a minute and plug in different values for x. I don't care what you plug in. And see if you can come up with a value that would make both of these true. Is there one x value that you can plug into both of these that makes it true? Pause this for about a minute. Go through a couple numbers and see if you can find any. Alright, you came back to me. Did you find any? Any one x value that you can put into both of these that makes it true? Okay? Well, if you guessed -1, you would have been correct. Because here's the first one. Look at your first equation, y equals 3x plus 2. If I plug in -1, okay, 3 times -1 plus 2, I do all my math, I end up with -1, okay? I kind of want you to not see this part for just a minute. Alright, that's okay. So plug -1 in for this equation. What do you get? Plug in -1. 5 times -1 is -5. -5 plus 4 is -1. -1 is equal to -1. I was trying to hide this y is equal to -1 for a moment, because here x is -1, and then because I made up this equation, y also came up to be -1. So what would be my solution? Since it has to be an ordered pair, what is my x value and y value that makes both of these true? I end up with check marks for both of these. What would be my ordered pair? -1 is equal to -1, and that's equal there. Do you have it? Well, my ordered pair is -1, -1. I plugged in -1 for x. Oh, there's my x coordinate. I get out -1. That is my y. Oh, there's y. So the ordered pair that makes this true for both is -1, -1. Pause that. Take that in for a minute. Look at it. Okay? When I put one value in for x here, it has to also give me the same value here. They have to be the same. This has to be a true statement. Okay? And both of these are. This came out to be -1 equals -1, and this came out to be -1 equals -1. They were both true statements. Okay? Somewhere like, I hope that you found that wouldn't work is if you ended up with maybe you ended up with 8 on this side. You know, over here. -1 is equal to 8. Well, that's not true, so that's not going to be a solution. Okay? There's one solution for this. Now, I don't know about you, but guessing and checking seemed pretty hard to do. Okay? We're going to come up with a more substantial way to do that, to solve these linear systems. Here's the next one. I just want you to look. Estimate the solution of the linear system graph below. Use a complete sentence to... I don't care about the complete sentence. Look at that. Where's the solution? First of all, how many solutions does this system of equations have? How many places do they cross each other? That would be just one, okay? They only cross at one spot. Now, estimate it. Pause it. Come up with the ordered pair where those two intersect. Alright, I hope you have it. X comma Y. Alright, my estimation was 2.5 comma 3.5. Because, let me get a little line here. I'm going to come straight down, and that looks to me like it's about 2.5. So my X value is 2.5. And then I come straight over, well this is 3, and it's between 3 and 4, so I'm thinking it's 3.5. So this is the solution to this system of equations, okay? This would make that statement true. If I plugged in X and plugged in Y, I would get the same going down. Alright, here we go. Now we have our special cases. We got a couple of those. Let me get the right tool here. How many solutions does this system of equations have? Well, it's a system. I got two here. I got two lines. They're both linear, so it's a linear system of equations. How many solutions is that going to have? How many times do these two lines hit each other? I hope you're scratching your head and saying, those are parallel. They're never going to touch by definition of parallel. Therefore, they will have 0 solutions. There is no ordered pair where these two are going to hit, okay? Ever. They're parallel. That's the definition of parallel. It's two lines that go on forever that never touch. They're not going to have a solution. Now, what I do want you to look at is I want you to calculate the slope for each one of these. Remember, that's rise over run, and you can simply count. You can count rise and count run. See what you get for the red line and for the blue line. Go ahead and pause me now and do that. I hope you came up with the slope of the red line is 1, up 1 over 1. The slope of the blue line is up 1 over 1, up 1 over 1. Parallel lines have what in common? They have the same slope. Parallel lines have the same slope. They will never intersect. They have 0 solutions. You need to write that down. That's important. Pause it right now and write it down. Parallel lines have the same slope. They will never intersect. So if I wanted to write an equation for these really quickly, red would be y equals, it was 1x, and let's see, where's the y-intercept? 1, 2, plus 2. Let me spread that out a little bit. And then let's do blue. Y equals, we know the slope is 1x, and the y-intercept looks to be at -1. Spread that out a little bit. Look at that. Those two lines have the same slope. Now, they have different y-intercepts. Yes, they hit the y-axis at different spots. But they have the same slope. So how many solutions are they going to have? None. 0. Zip. Alright, you got one more special case. Here it is. How many solutions does this system of equations have? I hope you're saying 1, because they're going to hit right here. Now, we're just going to estimate this because I do not have it fully calculated. And that's not the point, okay? Right there. I would say that solution would be over 1, 2, 3, and up 1, 2. It's a little bit more than 2, but we'll go with 2, okay? Just for right now. So the solution for the moment would be 3, 2. Now, you're going to get to actually calculate this and be more accurate. But for our point, it has one solution at approximately 3, 2. I want you to pause and calculate the slope. Calculate the slope of the blue line, calculate the slope of the red line, because this is important. Here they are. Slope of the red line, up 2 over 1. It also has a positive slope. Slope of the blue line, down 1 over 2. This one has a negative slope. Look at these two slopes. What can you tell me about that? I got 2 over 1, and then the other one I got -1 over 2. First of all, I hope you're thinking that these are opposites, okay? I have 2 on top, and then I end up with 2 on the bottom. Here I have 1 on top. Ooh, here I end up with -1 on the top. So first of all, one is positive, one is negative. And then they're backwards. One has the 2 on top, one has the 2 on the bottom. If they are perpendicular lines, here's what you need to write down right here. Okay? Perpendicular lines have negative reciprocal, let's use the math word for opposites, reciprocal slopes. One is positive, one is negative. That takes care of the negative part. One is 2 over 1, the other one is 1 over 2. That's the reciprocal part. Perpendicular, these are perpendicular. Perpendicular lines have negative reciprocal slopes. They're opposites, and one would be positive, one would be negative. Here's your practice. Okay? There's only 3 problems, so don't whine. Determine whether the graphs of each pair of equations are parallel, perpendicular, or neither. Show all of your work. Okay? So here's your 2 equations. Do we care about the y-intercepts? No. All we're looking at are the slopes. Do these 2 have the same slope? No. So they're obviously not going to be parallel, because parallel you have to have the same slope. Are they negative reciprocals? Well, here's 1 over 2, and this one is negative. Well, that one's positive, that one's negative, so it takes care of the negative part. What about reciprocal? 1 over 2. What's the reciprocal of 1 over 2? It's 2 over 1. I want you to pause this, because I'm just going to take the answers down. Okay? Pause it. You do 5, 6, and 7. Okay? Alright, number 5. Yes, these are perpendicular because their slopes are negative reciprocals of each other. Also, look, they multiplied the slopes together and they got -1. That's another way that you can test to prove that they're perpendicular. Look at these. Okay, 2 over 3 and 3 over 2. They're not the same, so they're not parallel. However, one is positive and the other is positive. They're both positive, so the negative part is not coming in here. Let's look and see what they have. These lines are neither parallel nor perpendicular. They have the same slope, and their slopes are not negative reciprocals. Okay? So these are neither. They're just going to have one solution, but they're not parallel or perpendicular. Let's look here. Last one. -5x, -5x. This slope is -5. This slope is -5. Are those the same? Yes, they are. These lines are parallel because they have the same slope. Guys, you have got to know y equals mx plus b. Okay? If you're still struggling with that, you need to go back and watch some of the lesson 5 point whatever videos. It's in chapter 5. And you have to know y equals mx plus b, because all of these are in y equals mx plus b form. And if you don't know that, you're going to be confused. You have to know that m is the slope and b is the y-intercept. Okay? Thank you.